Hello, this talk is going to be about Alexa audio. We're going to start with simple text, add some emotion, and eventually get to the beta feature of Alexa presentation language audio mixing. I'll say that in our household, we say Amanda when we're wanting to refer to her without invoking her. And notice that I said her, because although I know it's simply a physical device with some software behind it, Amazon goes to great lengths to reduce that barrier and make it easy to think about Amanda as a she. And you should do the same thing with your own skills, which is one of the reasons that APLA is such a nifty feature. Although I will say the documentation leaves a lot to be desired. And so I spent so much time trying to get this working myself that I thought I'd make a video so that no one else had to go through that same pain. My name is Brian Tarbox. I run Wabi Sabi Software. I'm an AWS community hero, and I run the Boston AWS meetup. I also have what's called a high engagement Amanda skill, which is Premier League, which talks about European or British football, soccer for Americans, which has gotten up to over 17,000 invocations a month. So let's dive in. So the simplest thing we can do is simple text. So here we just have a text string, and we say let's speak that text string in our response builder, and it's simple as can be. Alexa, ask Tarbox Kaylee for simple text.
This is a simple spoken response.
Alexa, stop.
Goodbye.
So that was as simple as could be. It's totally functional, and that's probably what most of the responses for most skills in a skill store sound like. But we can do better, and it's not that hard. So let's add some emotion. Emotion is basically added to the string that you ask Amanda to speak. Now, the actual string that we send to Amanda is called Speech Synthesis Markup Language, SSML. And you can add these special things to SSML to tell it to do different things. So in this case, we have a special tag made by Amazon that lets us say, Amanda, speak this in an excited tone. And then we tell it, okay, we're all done with emotions. And one of the things you may notice is that this text is a little bit longer than the other text. That's because it seems to take Amanda a little while to warm up to using the emotion that you ask for. So if you have a very short bit of text, you may not hear the emotionality. But let's try this. Alexa, ask Tarbox Kaylee for text with emotion.
This is a simple spoken response with emotion indicators. Liverpool wins the league, and so on and so on. Emotions take time.
Alexa, stop.
Goodbye.
So you could hear there that it took a little bit of time, but eventually Amanda started talking in an excited, high-pitched voice. Now, I would caution against using that too much in a skill, because you don't want your skill to be so perky all the time that people get tired of it, but used sparingly and appropriately, it can be quite interesting. In my Premier League skill, when I'm talking about teams that are doing well, there are various degrees of excitement. And when I'm talking about teams that are doing poorly, I add various degrees of disappointment. The next thing we can do, if you have a device like I have down in the lower right corner, if you have a device with a screen, you can add some text to it. So, because remember in the previous examples, Amanda spoke to us but didn't really say anything on the screen. In this case, we create a card So we create a simple card that just has some text, and we set the card. Alexa, ask Tarbox Kaylee for a simple card.
This is a simple spoken response with a simple card.
Alexa, stop.
Goodbye.
So you can see that we put text up in addition to speaking the text. That can often be very handy when you're presenting a lot of information and you want to give the person time to absorb it. So that's a simple card. We can take it a step further and use a standard card. Now a standard card will put up text but also put up a picture. So I've got an image URL that points to an image that I have cached often in CloudFront, and I create a standard card that has some text and has some images, and I can have different images depending on whether you're on a large or small device. But again, I just set the card. Alexa, ask Tarbox Kaylee for a standard card.
This is a simple spoken response with a standard card.
Alexa, stop.
Goodbye.
You notice in that case we put up a picture in addition to the text. And again, please adhere to copyright and don't use pictures you don't have rights to use. But putting up a card, putting up a picture in the card can be really quite interesting. Okay, now we get to the meat of things, which is audio mixing. And here's where we do things just a little bit differently. So one thing is, you'll notice that so far, every time we've included a .speech directive, okay? But here when we're in audio, we don't say .speech, because .speech is going to be handled by the directive. So we add a directive. And what directive do we want to add? Well, we want to render a document. Well, what the heck's a document? Well, we'll get to that. So in the document, render document directive, we provide a token, which is just anything you want, and then a pointer to a document, and optionally some data sources. Now the pointer to the document can be a link to a location that the system has saved your document internally, okay? And then all the text that should be spoken and any other sound effects that should be spoken gets said here. Now I will warn you, there are multiple flavors of the render document directive. There is the APL version and the APLA version. It's very easy to get those confused. If you use the wrong directive, you may spend hours or days in some cases figuring out why your skill is not saying anything. So be careful about using the correct directive. So now let's go, so here we say the source is this particular template. So let's go look at a document template. Okay, so this is a document template. And we notice we say up here ALPA. We've got some fields that I haven't really filled in too much. And then we have item. And the item lists what's actually going to be in the spoken response. Now in this case, I've used a mixer, which means I'm going to be mixing some spoken text and some audio clips. Okay, so my mixer is going to mix all the items in the items array. Now the first element of the items array happens to be a sequencer, which means I could have several different texts to say in a row. But I'm only wanting to say one thing at a time. And then down here, I'm going to have some text, and then I'm going to have some audio payload. Okay? So we'll go back to the main scene. So I'm going to say, I've told Amanda to render this document. The document consists of some text to say and some audio to play at the same time. Amanda, ask Charbox Kaylee to play audio mix. Alexa, ask Charbox Kaylee for audio mix.
Hey, this is hard-coded text that lives in the document template while there is crowd noise in the background.
So you could hear some text being spoken. You could hear
The
some
Hello World skill can't help you with that.
Alexa,
You
stop.
can say hello. Goodbye.
You could hear that there was text being spoken and some crowd noise in the background. And in fact, let me go back and show you the navigating away. Proceed. Yep. Okay. We're going to go to template without data sources because we want to get to data sources in a minute. But here you could see, hey, this is hard-coded text. And then here is hard-coded football sound. And you notice that we've said trim to parent. So the background sound will stop as soon as the parent text has finished being spoken. Now, one of the things you may have noticed is that the background sound was pretty loud. Okay, so let's figure out how we're going to fix that. Okay. So now we have audio mix with data source. So we have all the same things. We have our add directive, we have render document directive, we've got a pointer to a template, this time template with data sources. But you can see now we've provided some data sources. So we have some text that we will speak, and then we have crowd noise. And one of the things we want to do is randomize the crowd noise so that things don't seem quite as same all the time, because that's very computery. So we randomize where in that audio clip we should start. Alexa, ask Charbox Kaylee for audio mix with data source.
This is the text that will be spoken at the same time the audio clip plays. It is dynamic and set by the lambda.
Alexa, stop.
Goodbye.
So a couple things to notice in that example. One, that we were using dynamic text that we had in the lambda, so we can change it every time we run. The second thing is that the volume was quite a bit reduced, which is handy. So there are all kinds of filters you can use for volume, ramp up, ramp down, and so on. Now, one of the tricks is associating your data sources here with the placeholders in the template. So this diagram shows the relationship. So your data sources in your lambda form a map that maps over to the references in the document directive. So you can see that text speech maps to text speech, and crowd noise goes to crowd noise, and crowd start goes to crowd start. So you want to make sure those match up, or else things won't work. Okay. The next thing to look at is how you do editing. So this is basically the template editor. Now the audio sonogram at the bottom of the screen shows you the sound pattern that you're going to be playing. The play button in the bottom left obviously does the play. Now the interesting thing is you can if you make a change in this editor and just push play, you won't get the changes. You have to push the circular button in the bottom left in order to get it to change what's being played inside the editor. But that still isn't enough to get it to be seen by the Lambda. For that, you have to hit the Save button in the upper right that looks like a floppy disk, for anyone who remembers what floppy disks look like. At that point, your document template has been saved. You still have to go back to the Alexa console and save the model and build the model. If you don't do that, you can spend a lot of time in this editor making changes that don't ever seem to appear inside the Lambda. The last thing I'll show you is that if you do anything wrong, Alexa will often just say error, and it will give you a runtime error, but it won't tell you what the runtime error is. It will give you no information about it, and that, of course, is incredibly annoying. Try not to do anything wrong. But the better advice is make small changes, save them to Git periodically, and test. And if you make a change, just go back to a previous version. Because figuring out what the actual error is that it's complaining about can be very annoying. So in the end, this can be very simple when it works, but it took me a long time to get here. And I'll post this code to my website, and I hope it saves you some grief. Thank you.